Welcome to this exploration of balloon academic papers. This is an exploration of high-altitude balloon papers, me, commentated, narrated, as a balloon consulting expert in scientific, long-duration, high-altitude weather balloons. So the paper we have here today is one of the foundational papers for modern high-altitude balloons. This is from 1947. Controlled altitude free balloons. Let's take a look through this paper and see what we see that's interesting. So looking at our abstract here, the results, let's see. It says they'll be flown at constant pressure in the atmosphere. What that means is that they're going to be flown at basically the same altitude the whole time, though in practice, in the real environment, that means that they will go up and down very slightly as the air pressure changes. Air pressure such as you hear on weather reports. And as you see, they have just developed plastic balloons, and they added an automatic ballast system and some other data. Let's take a look. And they mention that the constant level balloon may provide data that is not obtainable from an ordinary pilot balloon network. This means that pilot balloons, which are white, round, latex weather balloons that you may frequently see amateurs fly, or the National Weather Service or your country's weather service flying for getting weather data, they can't do what the constant altitude balloon can do. And that is because those white weather balloons, when they are released, they climb until they pop, and then they fall down on a parachute. That means their practical flight lifetime for weather instruments is only about 2 hours up and about an hour and a half to 2 hours down. Constant level balloons, however, will rise up and then stop at a particular altitude, and then just drift with the winds for long distances and possibly long times. And this allows you to get measurements of weather in sort of a tracing path that's not available from regular latex balloons, which are just basically a single location measurement from bottom to top of the atmosphere. Let's take a look here. So drift bottles, that's curious. I assume that might mean bottles they throw into the ocean like messages and then find them someday. In 1947, they would not have been able to use radio tracking, certainly not GPS. They wish they had this drifting marker technology for the sky. Yeah, cosmic rays. That's a good point. Cosmic radiation is something that is very valuable to use balloons to measure. And that is because cosmic rays come into our atmosphere at very high speeds and then crash into air molecules. And then they basically make the air molecules explode into a shower of other high speed, high energy atomic particles, which then scatter out like tree branches and smash into other air molecules. This basically becomes a giant game of pool billiards from a cue ball that comes hurtling in from outer space. And this is all happening at the molecular atomic level. But as you can imagine, this tree branching cluster crashing effect starts high up in the atmosphere. And by the time it gets to the ground, the energy has been really lowered. Like the collisions are getting slower and the speeds are less and weaker by the time they get to the ground, where we used to have to measure the cosmic ray fallout. Sorry, not fallout per se, but the resulting debris, atomic debris from the cosmic ray smashes at the top of the atmosphere. So it's kind of hard to trace back a lot of information after you've gone through like 100 different splits and collisions. But the neat thing about balloons is that the cosmic rays usually crash into air molecules around the bottom of the stratosphere. And that is where balloons do really well. Cosmic rays don't actually happen very often, so individual pilot latex weather balloons going up for 2 hours and down for 2 hours may only spend a half hour at the bottom of the stratosphere. That's the top end of their flight range. And that means you don't have much time to catch cosmic rays because cosmic rays don't happen very often. Um, it might be minutes or hours between uh, cosmic rays coming through your local area of the atmosphere. So it's really necessary to have a balloon that just sort of hangs out up there and waits. Let's see what else we have. That's true. Controlled free balloons, these constant altitude balloons, uh, may be set to drift at any pressure elevation. What that means is you can build your balloon and you can put enough gas in and attach enough weight to allow you to adjust the altitude that it actually flies at. This is an interesting application for the balloons. They dreamed that these balloons just floating, drifting at one level far above may be used to drop radiosondes over the oceans. And a radiosonde is a package of weather sensors that measure temperature and humidity and pressure, altitude. And that is what usually hangs on the regular pilot latex weather balloons. Over the oceans, however, we can't launch balloons. And balloons used to be, and actually still are, one of the primary sources of weather data in the world. And that means that, 7/10 of the planet has no weather data that is this detailed. And so the idea of balloons drifting over the ocean, dropping little radio sensor boxes down to the ocean, allows you to make this little vertical column of measurements as it's falling. It's recording and transmitting all the values through all the altitudes on a little tiny parachute. And this gives you what you would have gotten if you had a weather balloon out there on a ship. And so that's pretty cool. That's curious. I'm not sure what that means, but perhaps it will become more apparent later in the paper. I'm going to go ahead and wrap this stream up. This is just my first test stream to see how things work. So thanks for watching. Bye-bye.